Hello and welcome to the third in a series of videos looking at climate change and whether what we've been told by the media is correct or not. In this video we'll be looking at net zero and asking the question, will it save the planet or just make us poor? King Canute was a Danish king of England who ruled from 1016 to 1035. He's most famously known as the king who tried to stop the tide. When he realised he could not, he is supposedly to have said, "To let all men know how empty and worthless is the power of kings, for there is none worthy of the name, but he whom heaven, earth and sea obey by eternal laws." So why is it then today that we believe we can control the climate through net zero? Net zero aims to achieve a balance between the amount of carbon dioxide emitted into the atmosphere and the amount of carbon dioxide removed from it. The UK's Energy Savings Trust goes on to state that to reach net zero, emissions from homes, transport, agriculture and industry will need to be cut. However, it is not as simple as that for a number of reasons. Wind and solar power is intermittent with no reliable storage mechanisms. Manufacture of electric vehicles, solar panels and wind turbines are actually carbon intensive. The reduction in CO2 emissions in the West are not being matched by China, India and others. Carbon dioxide may not actually be driving the temperature increase after all. And there is a shortage of materials for an all-electric future. We'll look at each of these reasons in greater detail. The former UK Prime Minister, Boris Johnson, famously stated that he wanted the UK to become the Saudi Arabia of wind power. However, as the graph below for September 2023 from UK Gridwatch shows, wind power, which is shown in light blue, can be highly variable. On the 19th of September at 2 AM, it was able to supply 58.1% of the UK demand. However, on the 8th of September at 8 AM, it only supplied a mere 0.399%. Similarly, with solar, which is shown in yellow in the graph, it was able to supply 25.3% of demand at the 12th of September at 12 noon. But in the evenings, it obviously doesn't provide anything. The shortfall is currently made up with either gas, shown in the orange, or by importing electricity from Europe, which are the browns and pinks in the graph. The imports are often at exorbitant prices. In July 2022, the National Grid paid Belgium £9,724 per megawatt hour, which is something like 50 times the normal price. Clearly, wind and solar then are not reliable. And as gas is about to be phased out, we will be looking towards power outages and blackouts, something that the UK hasn't experienced significantly for over 50 years. A further concern with wind and solar is that their peak availability does not always correspond to peak demand. In the graph on the previous slide, peak wind was at 2 AM in the morning, and demand was at its lowest. Peak demand is normally between 5 PM and 8 PM in the evening. In addition, there is considerably less sun in the winter time when the demand for electricity is higher. At present, that shortfall is made up from gas and supply from Europe. However, as gas is to be phased out, other backups will be required. Batteries, pumped hydro and hydrogen are possible storage mechanisms, but each have their own challenges. Hydrogen, for example, can be either stored as a liquid or a gas. But liquid hydrogen requires cryogenic temperatures lower than -252 degrees centigrade. It's extremely expensive to get temperature into that temperature and to stay at that temperature for a considerable period of time. Hydrogen is also not that efficient, with a efficiency of less than 50%, meaning it takes more than twice as much energy to store the hydrogen than you get back from it. where the UK, 150 terawatt hours is estimated to replace natural gas. In terms of batteries then, the world's largest battery is in Hornsdale, South Australia, and it was built with an initial capacity of 129 megawatt hours at a cost of 90 million Australian dollars, or £47 million. It has a flow rate of 100 megawatts, meaning it can operate at maximum capacity for about an hour and a quarter. It was subsequently expanded to 194 megawatt hours with a flow rate of 150 megawatts, but still an overall capacity of time of 1 hour and a quarter at an additional cost of 82 million Australian dollars, or £43 million. This graph shows the daily average for UK consumption. The maximum, as stated below, is 46.446 gigawatts, or over 46,000 megawatts. To provide the battery storage for the UK grid, would require over 300 Hornsdale batteries at a staggering cost of £2.76 trillion, which is more than the entire UK economy. So how are we going to afford that? In addition, it also only gives us battery capacity for that hour and a quarter. Pumped hydro is a further source of energy storage. During peak demand, water can be released from an upper reservoir through turbines that generate electricity into a lower reservoir. It's then pumped back up to the upper reservoir during non-peak periods. Pumped hydro is more efficient than hydrogen storage, but at 85% it is still a net consumer of energy, i.e. it requires more energy than it gives back. As a result, there are only 4 pumped hydro systems in the UK as shown. Of these, the Norweg is the largest and can produce 1.7 gigawatts. With a total capacity of 9.1 gigawatt hours, it can run at peak capacity for just over 5 hours. It cost £425 million in 1974, but the equivalent cost today would be £4.5 billion. To cover the UK peak of 46 gigawatts, it would require a further 27 Norwegs at a total cost of £121 billion. That would only provide 5 hours of cover for the grid, assuming of course there are a sufficient number of reservoirs in the correct position. As the UK is actually going without wind for 9 days, it would require 1,166 Norwegs at a total cost of 5.2 trillion to cover the 9 days without wind. In 2022, the UK economy is only 2.23 trillion, so that would be equivalent to paying 2.5 times the size of the entire economy of the UK to provide battery storage, pumped hydro storage. Currently, there are only 6 pumped hydro sites planned in Scotland, with a total capacity of 4.9 gigawatts. Are EVs emission free? The Nissan Leaf proudly states that it is zero emissions, as shown in the door badge in the picture below. Yet Nissan themselves claim that the Leaf only saves 32% of life cycle emissions compared to conventional vehicles of the same class. So my question for you is, how can a zero emissions car only save 32% of life cycle emissions? Why is it not 100%? Similarly, Volvo in a 2020 report into their new C40 electric vehicle showed that based on a typical electricity mix of 60% generating fossil fuels, which is something we can expect for decades to come, a C40 would produce 50 tonnes of CO2 over its lifetime, as opposed to 59 tonnes of carbon dioxide for a petrol XC40. That's only a 15% saving. Clearly, electric vehicles are not emission free, in which case, how can we reasonably expect to save the planet if we're still going to be pumping out carbon even when we all drive electric vehicles? If electric vehicles are not emission free, what about solar panels and wind turbines? Do they fare any better? According to the eco-experts, it takes 3 years for a solar panel to break even in terms of CO2 emissions, with a CO2 equivalent of 41 grams per kilowatt hour. Wind fared better with only 11 grams per kilowatt hour. And while both are better than gas and coal, they're not as emission-free as we've been led to believe. But recycling is a major challenge for both wind and solar. The wind turbines, in particular the blades, cannot at present be recycled. In fact, they're just sent to landfill as shown in the picture. And 90% of solar panels are also currently not recycled. So at the end of their 20-year lifespan, we're going to have an incredible waste problem, as well as a challenge of finding new materials to provide for the next generation of wind and solar. Okay, have we actually seen a reduction in CO2 emissions as we move to net zero? Well, the International Energy Agency provides statistics on energy usage amongst other things. Western countries such as the UK, Germany and the US have cut emissions since 1990. The UK has cut by 40%, Germany by 36%, and the US by 11%. However, countries such as China and India have more than eliminated the benefit of the West reducing carbon emissions. China has increased its CO2 emissions by 381% and India by 291%. As a result, the world as a whole has increased its CO2 emissions by 54% since 1990. Unless then we start seeing all countries cutting emissions, it is no more than economic suicide for the West to give up reliable and dependable energy sources and replace them with intermittent alternatives. Despite cutting by 40% in the UK, carbon emissions worldwide have gone up by 54%. Why is the UK even bothering? We are not going to save the planet. All we're going to do is make ourselves poorer. So, is the increase of CO2 natural or man-made? Well, the Intergovernmental Panel on Climate Change, in its 6th assessment report, AR6, states that it is unequivocal that the increases in atmospheric carbon dioxide, methane, and nitrous oxide since the pre-industrial period are caused by human activities. However, there is now significant evidence emerging to suggest that this is not the case. Delay and Scrabble have both indicated in their studies that the human element is only between 40 and 50 parts per million, rather than the full 140 parts per million claimed by the IPCC. That would mean that 2/3 of the CO2 increase that we've seen is actually natural and not man-made. Geigsvig and Moen in their 2023 study, published by Statistics Norway, concluded that the effect of man-made CO2 emissions does not appear to be sufficiently strong to cause systematic changes in the pattern of the temperature fluctuations. In other words, their analysis indicates that with the current level of knowledge, it is impossible to determine how much of the temperature increase is due to emissions of CO2. So, now we see that some of the increase is natural and not man-made. We also cannot tell how much of the increase in temperature is a result of carbon dioxide. Finally, we wanted to look at the materials and whether there would be a shortage of raw materials for an all-electric world. Simon Michaud is an associate professor at the Geology Institute of Finland. He has been conducting research into what would be involved for the world to go fossil fuel free. Some of his findings, though, are quite concerning. To replace internal combustions or ICE vehicles with electric vehicles would require the manufacture of 1.4 billion lithium-ion batteries, with a combined weight of 339 billion tonnes. However, the 15 countries in the world with the largest known lithium reserves only have a combined reserve of 26 million tonnes. That's a shortfall of only a mere 313 million tonnes. Even with the best will in the world, it will be impossible to create a proper electric vehicle revolution. Similar challenges apply to other rare metals, and copper in particular. We can expect shortages for. Simon also goes on to say that to completely electrify the existing internal combustion engine fleet in the world would require an additional 10,895 terawatt hours of electricity. To achieve this kind of scale, we would require the building of an additional 64,000 additional average-sized power plants. And yet in 2018 worldwide, there were only 4,423 such power plants. On average, it takes somewhere between 10 and 15 years to build a new nuclear plant, so carbon neutral by 2050 is going to be an enormous task. One I would suggest that is not achievable, certainly in the current rate. So then, in conclusion, net zero by 2050 was always going to be a massive challenge given the scale of the change required. Wind and solar are intermittent, with no reliable storage mechanisms. Solar peaks in the summer when demand is low, while wind peaks in the middle of the night, again when there is low demand. Storage mechanisms are inadequate and prohibitively expensive. For the UK alone, the bill will be higher than its entire UK economy. Electric vehicles are not as emissions free as we've all been led to believe. While the West has reduced emissions over the last 30 years, the world's overall CO2 emissions have increased by 40%. In addition, there is a shortage of the raw materials required to make net zero happen. Finally, there are also now question marks over how much impact the increase in CO2 is having on temperature. All of this leads to the conclusion that net zero is no more than a pipe dream, and for the UK to be at the forefront of it is incredibly silly, an act of economic suicide that truly is nuts. China has only committed to net zero by 2060 and India by 2070, so the UK being a supposed leader isn't going to make any difference. It certainly won't save the planet, and all of us will be poorer for it. And yet what do we find? After a failed offshore wind auction as subsidies were too low, the UK government has now agreed to pay 66% more for offshore wind. It truly has lost the plot. Thank you for listening, and if you've enjoyed this video, please like and subscribe. Thank you.